Find the equation of the tangent line at the point 2, -1 on the following curve. So we have this equation here, y squared plus x squared y cubed plus 11 equals 4x. This equation is not easily solvable for y. So we need to use implicit differentiation to find the derivative. When you use implicit differentiation, you can take the derivative of y just like you would the derivative of x. But every time you take the derivative of y, in this case we would use the power rule, 2y. When you take the derivative of that term, we need to attach to it a y prime. When we look at the second term, we have x squared times y cubed. Since we have this multiplication happening between the x squared and the y cubed, we need to make sure we use the product rule for this particular term. So the product rule states we use the first function, in this case the x squared, and we're going to multiply the derivative of the second function. And to that we are going to add the second function and multiply to that the derivative of the first function squared. Here we go. The derivative of 11 just turns into 0, as the derivative of a constant is 0. And on the other side of the equation, we have the derivative of 4x. Using the power rule here, the derivative of 4x is just 4. So now from our product rule, we need to find these derivatives. So we still have 2y times y prime plus x squared, and when we take the derivative of y cubed, we treat it just like the x, we use the power rule. So we're going to multiply this by 3y squared. But since we're taking the derivative of y, we need to attach a y prime. Continuing, we will add to that y cubed times the derivative of x squared is 2x, and that equals 4. Now we need to keep all the terms with y prime on the left side of the equation and move anything without a y prime to the right side of the equation. This leaves us with 2y y prime plus x squared times 3y squared y prime equals 4 minus y cubed times 2x. In this next step, I'm going to common factor out the y prime from both of these terms, and I'm going to clean up these other terms a little bit. So this will leave us with a y prime times 2y. The second term, when you multiply x squared times 3y squared, that just leaves you with a positive 3x squared y squared. And on the right side, we have 4 minus. When you look at these two expressions being multiplied, we can just rewrite that as 2xy cubed. And then the last step that we need to do to solve for y prime is divide both sides by 2y plus 3x squared y squared. And that allows us to find that the derivative y prime equals 4 minus 2xy cubed all over 2y plus 3x squared y squared. Now that we have our derivative, we can start finding the slope of a tangent line. Remember, when you find the derivative, whatever your answer is, as long as we have an x and a y value, will give us the slope of a tangent line. Luckily, given to us in the original exercise, we know that we are dealing with the point 2, -1. This is our x value, -1 is our y value. All we have to do is substitute those numbers over here into our derivative to find the slope of a tangent line. So in the numerator, this leaves us with 4 minus 2 times 2 times -1 to the third power, all over 2 times -1 plus 3 times 2 squared times -1 squared. When you simplify the numerator and denominator, you'll see that you get 8 over 10, which reduces to 4 over 5. And that is the slope of our tangent line. We're almost done. Now we need to find the equation of the tangent line. The equation of the tangent line, since we have a point and a slope, is very easily found if you use the point-slope form of a line. That is y minus y1 equals m times the quantity x minus x1. Then all we have to do is substitute in our numbers. x1 is the x-coordinate in our point, y1 is the y-coordinate in our point, and the slope m is 4 over 5. So we can just substitute these numbers in. Y minus -1 equals 4 over 5 x minus 2, which tells us that y plus 1 equals 4 over 5 x minus 2 is the equation of our line. If you like the slope-intercept form of a line, all we need to do is distribute this 4 over 5 and subtract 1 from both sides, ideally or essentially solving for y. And that equation in slope-intercept form is y equals 4 over 5 x minus 13 over 5. Either one of these answers is a good answer, and this is the equation of the tangent line on the original curve when at the point 2, -1.